My name is Beth Griffin, and I am a senior statistician at the RAND Corporation, where I'm co-directing the RAND USC Opioid Policy Tools and Information Center, OPTIC. I'm pleased to provide this video abstract from our recent OPTIC paper on identifying optimal methods for addressing confounding bias when estimating the effects of state-level policies. This will be published in Epidemiology and was supported by funding from the National Institute of Drug Abuse. Studies that assess how a given policy affects certain health-related outcomes are foundational to health and social policy research. However, evaluations of state policies face several methodological challenges. Confounding is a well-recognized source of bias in such studies. However, the unique considerations of confounding in longitudinal settings, including differences of evaluations, have received less attention. In this paper, we examined the role of confounding in longitudinal diff and diff studies to understand the implications of confounding in state policy evaluations and the relative performance of traditional versus recently developed methods. We compared 4 statistical models: the classic two-way fixed effects model, a one-period lagged autoregressive model, augmented synthetic control, and a doubly robust approach from Callaway Santa Ana. The models differ in how they address confounding. The two-way fixed effects and autoregressive models rely on parametrics corrections, while augmented synthetic control and Callaway Santa Ana are using design-based approaches to improve comparability of treatment and control states in any given year. Because it's impossible to test model assumptions in practice, we used a simulation study with a known data generating process to assess the relative performance of these methods under scenarios with small, moderate, and large levels of confounding, as well as linear and nonlinear scenarios. We conducted all the simulations in our R package, which is called OPTIC and can be used on any repeated measures data to reproduce the simulations with your own research data. Our results showed some interesting findings. No single method outperformed the others across the simulation conditions. Augmented synthetic control performed the best when looking at mean squared error, with low bias and really low empirical variance. However, coverage rates for augmented synthetic control notably exceeded the nominal 95% level, which reflects high model-based standard errors in practice. The autoregressive model performed well, yielding low bias and more reasonable coverage rates. The Callaway Santa Ana method performed the best in the most difficult scenario of nonlinear confounding by prior outcome trends. Our findings must be considered alongside the study limitations. Critically, all the simulation studies had homogeneous treatment effects that didn't vary over time and location. Future research should really explore the relative performance of these and other methods in the presence of such heterogeneity.